Hello students. So today coming up with the second part of the numericals based on the chapter machines, and in the second part of the numerical we will have specifically about pulleys, but those technical terms which we had seen in the first part, that is mechanical advantage, velocity ratio and efficiency, will be used. We will have to take a look into the different types of pulleys, like a single fixed pulley, then a single movable pulley, then a fixed pulley with one movable pulley, and the block and tackle system. In all these, what you will require is to know the mechanical advantage, velocity ratio and the efficiency in ideal condition. Ideal condition means we will not be considering the weight of the pulley there and the friction which will be caused. Only in the end, in a block and tackle system, you will be seeing when the weight of the lower block is considered, what happens to the mechanical advantage, velocity ratio and efficiency. So one by one, we will go through each one of them, and in all of them, basically we will have to see how do we get the mechanical advantage, velocity ratio and efficiency. So starting first of all with a single fixed pulley. So there is a rigid support, a single fixed pulley is there. This pulley can't move from its place, that is why it is a fixed pulley. We have a load here acting in the downward direction. The weight of this body is the load, and from the other end through the string, the effort is applied in the downward direction. So you know that a tension in the string will be acting. So this load is balanced by this tension and this effort is balanced by this tension. So load is single time of effort, of tension, and effort is also single time of tension. So remember, mechanical advantage was load by effort. So if we calculate here the mechanical advantage L by E, L will be replaced with T, E will also be replaced by T, T getting cancelled will give it as 1. So first of all, for a single fixed pulley, mechanical advantage will come as 1. So you have to remember, whenever any numerical based on single fixed pulley is there, we can take the mechanical advantage directly as 1, provided the load and the effort is not mentioned in that. If the load and the effort is mentioned, you will have to take out the mechanical advantage by using load by effort. Now velocity ratio, it is the displacement of the effort divided the displacement of the load. So if this load is moved up, as this is being pulled down, it will be going up. As this one is going up, so if I consider that this rises by 1 meter, so this end of the rope will also come down by 1 meter. So if the displacement of the load is 1 meter, displacement of the effort also will come as 1 meter. So putting in the formula of displacement of effort by displacement of load 1 by 1, it will give us 1. So velocity ratio is also 1 in a single fixed pulley. Then you know efficiency is mechanical advantage by velocity ratio. Both are 1. This is an ideal condition we are taking. So mechanical advantage 1, velocity ratio 1 get cancelled. So the efficiency will come as 1, or in percentage it will come as 100%. So this will be 1, or I can write it as 100%. So efficiency in an ideal condition for a single fixed pulley comes as 1 or 100%. Now the second one, which is a single movable pulley, this is a rigid support. This pulley is here with a load hanging. As this string will be pulled upward, this pulley will be rising up as well as the load will go up. So here the pulley is not fixed at its place, so that is why it is a movable pulley. Now what happens here to find the mechanical advantage? Remember, it is load by effort, and so here this load is balanced by this tension and this tension. So here the load will come as 2T, okay? L will come as 2T. Now this effort will be balanced by a tension acting here. So E will come as T. So let us come to the mechanical advantage part, let us write here single movable pulley. So mechanical advantage will be load by effort. Load is 2T, effort is T, T cancel will give you 2. Then we come to velocity ratio. Remember, velocity ratio is the displacement of the effort by the displacement of the load. If this load is going to rise here upward, what happens? The string will get shortened on this side as well as this side. So what happens if this has to rise by 1 meter, the rope on this end should decrease by 1 meter as well as in this end should decrease by 1 meter. It means at the place where you are applying the effort, you will have to pull the rope twice the length of whatever rises up here. So whatever we take the displacement of the load, displacement of the effort will come twice of that. So going by the formula displacement of effort by the displacement of load, you will get the velocity ratio for a single movable pulley as 2. So I write it here as 2. So mechanical advantage is 2, velocity ratio 2. So as a result, efficiency will be 2 by 2. That will give you 1. So here also efficiency will come as 1, or you can write it as 100%. Again, I remind this is an ideal condition. So if you are given a single movable pulley is told, you can take mechanical advantage as 2 and velocity ratio as 2. But if it was provided with the value of load and the effort, you will calculate mechanical advantage with load by effort, will not take 2, but velocity ratio will be taken as 2. Keep this in mind. Now let us come to a single movable pulley with a fixed pulley. So we are using one fixed pulley here and this pulley is movable. So in that case, what happens to the mechanical advantage, velocity ratio and efficiency in an ideal condition? So first of all, this load is being balanced by these two tensions. So I will be getting here load is equals to 2T and this effort is being balanced by this tension. So I get here effort is equals to tension. So if I use mechanical advantage formula, load by effort 2T by T, that will give us the mechanical advantage as 2. Now the question says, what is the benefit if mechanical advantage is 2 same in both the case? A big advantage here is that in the previous one with a single movable pulley, the effort was to be applied in the upward direction against the force of gravity. In this condition, with the help of another fixed pulley, we are applying the effort in the downward direction, which is a convenient direction. The weight of the body also can be used in pulling the object. So that is the benefit in this case. Now for the velocity ratio. So displacement of the effort by the load, if this will be rising up, okay, 1 meter. So for this to rise in 1 meter, 1 meter should get reduced in this end of the string or the rope as well as at this end. So ultimately, if this one and this one gets reduced, the string has to be pulled here by 2 meter for this to rise by 1 meter. So similar to what we had seen in a single movable pulley. So here the velocity ratio will come as 2, and then going by that same way, the efficiency will come as 1 in an ideal condition. Now we go to see what happens to the three quantities which we have been seeing in a block and tackle system. So follow, in a block and tackle system, there are two ways. There is one block at the top and there is another block at the bottom. Two systems are there. Whatever number of pulleys you have in the upper block, the lower block should have one pulley less than that. That is one of the system. So in that case, the total number of pulleys will be in odd number. And in this case, the upper block as well as the lower block has got same number of pulleys. In this case, you can see two pulleys are there in both. So this is the way it has to be done, means the number of pulleys in the two blocks has to be maintained in this way. You should not have here the number of pulleys which is there over here, one more than that, we don't have that. Okay. So now let us see what happens here. This lower block actually will be there at the bottom from where the load has to be lifted. There will be quite a big gap, and this will be the block which will be there up to what height it has to be raised. Here it has been shown very close to each other, but in actual condition it won't be like this. So if we are looking for mechanical advantage, so let us follow how much the load will come. There are altogether 5 pulleys. The joining here, when there are one pulley less than the upper block, is from the hook of the lower block. And when both are same, the joining starts from the hook of the upper block. This has to be remembered. This also get asked in the examination. Okay. So of the lower one, it goes to this pulley and then comes down to this one, the first pulley in the lower block. Then it goes to the second pulley in the upper block, comes down to the bottom pulley in the lower block, and then finally to the top block. Effort is acting downward in this case. There will be other case where the effort is acting in the upward direction also. So here the load altogether is balanced by how many tensions. Take a look, 1 year, 2 year, 3 year, 4 and 5. These tensions are balancing the load. So you get 5T, and the effort is being balanced by a single T. So if you go to find the mechanical advantage, 5T by T will give you 5. So a simple way to relate, whatever is the number of pulleys, mechanical advantage comes to that value only. You can check out in this also. Here 1, 2, 3 and here 4, 4T. Effort will be balanced by this T. So load by effort, mechanical advantage will come as 4. So mechanical advantage in these two conditions of the block and tackle system will always come as the total number of pulleys. So we write here mechanical advantage equals to N. N stands for the number of pulleys, that is the total number of pulleys. Now for the velocity ratio. See, as I told, keep in mind this will be completely at the lower part. So whenever this load will get lifted by, think 1 meter. So for it to be get lifted by 1 meter, this part, this 3 of them, 4 and 5, all these 5 strands length should get reduced by 1 meter. So everywhere at 5 places 1 meter becomes 5 meters. So this rope has to be pulled by the effort 5 times the length of whatever the load rises. So the effort, displacement of the effort will become 5 times of the displacement of the load. So going by the formula and finding the velocity ratio, as I said, displacement of the load, if it is 1 meter, for the effort it will be 5 meters, so it becomes as 5. And then efficiency will come as 1 because both the values are same. So remember, in this case, effort was acting in the downward direction. So I am showing here effort is in downward direction. Keep in mind, when effort is in the upward direction, the results will change. So we can have also an arrangement, okay, where the effort will be there in the upward direction. So as a result, when effort comes in the upward direction, another strand extra will come which will balance the load. As a result, what will happen? Mechanical advantage will become 1 extra. So I write here mechanical advantage will become N plus 1. Same way, velocity ratio will become N plus 1. Remember, I had written here 5, but if I have to write in terms of the number of pulleys, velocity ratio here will come as N. Okay, I have written there 5. Again, I am reminding, if number of pulleys is N, we should write it in terms of N. And efficiency here, in this case also will come as 1. Remember here, effort is in upward direction. So that has to be remembered. So very important, Again, I repeat, we write the mechanical advantage velocity ratio directly. But if load and effort is given for mechanical advantage, we will have to find with load by effort, and velocity ratio will be by this formula only. Okay. Now, till now, we were not considering the weight of this block. But if I take the weight of the block which is being lifted, then the mechanical advantage and the efficiency will change, but velocity ratio will not change, because due to the weight, the displacement of the effort and the load will not change. So let us see what happens in that case. If we will be taking the weight of the lower block to be as W, okay, so W is the weight of lower block. So now we will be lifting that lower block weight also. So in this case, the mechanical advantage, I am not going for the derivation of it. So I will be writing it directly. The mechanical advantage will not be coming as N. It will come N minus W by E. So N is the number of pulleys. If it is 5 pulleys, then 5 will come there. 4 pulleys, then 4 will come. W will be the weight of this lower block which is there, and E will be the effort which you will be applying. Okay. And then velocity ratio will not change. It will be N, because there is no change in the displacement of the effort and the displacement of the load. But because this is different mechanical advantage, efficiency will be coming different. We will have to divide mechanical advantage by velocity ratio. So if we solve, we will get 1 minus W divided with N times of the effort. N times of the effort. So if you are given the weight of the lower block, you cannot apply this and do it. You have to do by this way. So these are the formulas and the concepts which you will require for this second part numerical of the machine chapter. Let us begin with the numerical of this pulley part. Let us take a look at the first one. A woman draws water from a well using a fixed pulley. Always keep in mind when you read the question which type of pulley is told. The mass of the bucket and water together is 6 kg is the mass. So the weight will become the load here. So we will find the weight by using M into G. Okay, so that will be the load here. The force applied by the woman is 70 Newton. That is the effort. Calculate the mechanical advantage. G is given as 10 meter per second square. So first of all, I will be finding the load. Mass is given, so I'll get with M into G, which is 6 kg is the mass. So 6 into 10 gives me 60 Newton. So I get this part. Now effort is 70 Newton. So I write here mechanical advantage is equals to load by the effort. So see, fixed pulley was told. So mechanical advantage of fixed pulley is 1. We cannot write that directly because load and the effort is given here. So load I have is 60 and the effort applied is 70. So 0 cancelled. So 6 you have to divide it with 7. So 0 point, it becomes 60. 7 8s are 56, 4 is left. So 40 is there, then 7 5s is 35, 5 is left, 50. So it will go, so 50 is there, 7 7s are 49. We have brought till 3 places. I think that is enough. It will keep coming. So we get mechanical advantage as 0.857. This numerical is done. Now let us come to numerical number 2, which says a fixed pulley is driven by a 100 kg mass falling at a rate of 8 meter in 4 seconds. So because of that 100 kg mass which is falling, the effort will be applied. It lifts a load of 75 kgf, because of which a 75 kgf weight is being lifted. Calculate the power input to the pulley. So input will come from the effort. So we should know the work input. Work input will be the force into displacement. Force taken will be the effort because of that 100 kg mass falling. and we have been asked to take 1 kg as 10 Newton. With that will help us in converting that mass into weight. Then we are asked to find the efficiency of the pulley and then height to which the load is raised in 4 seconds. So you know that it is a fixed pulley, velocity ratio is 1, and in that case the displacement of the effort and the load is the same. So here the displacement of the effort is 8 meter. So here the height to which it will get raised in that same time 4 seconds will also be 8 meter. Let us write it over here and do it. So first of all we have to find the power input. So I will go to find that power input by finding the work input first. Will be the force into the displacement. Here the force will be 100 is the mass multiplied with the g value makes it the weight of the body, which is the force, and the displacement is 8 meter. So I get it here as 8000 joule. Now I can find the power input by using work done by time. Work here is the work input. So that is 8000 and the time is 4 seconds. So I get it as 2000 watt. This is the A part which we have done here. Okay. Now after that, efficiency of the pulley is asked. Efficiency is mechanical advantage by velocity ratio. So first let us find the mechanical advantage of this. So load by the effort. So load over here is 75 kgf. Effort is that 100 kg mass falling. So the weight in kgf, because load is given in kgf, I will write it as 100 kgf. With 25 threes are 25 fours that get cancelled. So I get 3 by 4 as the mechanical advantage. The pulley given is a fixed pulley. So a fixed pulley has a velocity ratio of 1. So I will write here velocity ratio 1 directly. And now efficiency is mechanical advantage by velocity ratio. So that is 3 by 4 and then velocity ratio is 1. So 3 by 4 will give me 0.75. I did not find in percentage, so I have not involved 100. So I can write 0.75. If I would have multiplied with 100, I would have got the efficiency as 75%. Then the height to which the load is raised for this part, VR is equals to displacement of the effort by displacement of the load. Velocity ratio is 1. Displacement of the effort is given as 8 meter and the displacement of the load we have to calculate. So cross multiplying will give us 8 meter will be the displacement of the load. I hope you have understood how this numerical has been worked out and able to relate mainly the mechanical advantage when we can use directly and when we have to do it with load by effort. Now let us come to the third numerical. It says a single fixed pulley and a movable pulley. Both are separately used to lift a load of 50 kgf to the same height. So there is one fixed pulley and there is one movable pulley. Both are lifting that same load of 50 kgf to the same height. Compare the efforts applied in an ideal situation. So it is an ideal situation. We have to compare what effort will be there applied in a single fixed pulley, compare it with what happens in a movable pulley. So for this, we will calculate the effort in both the case and then compare it. So first of all, it is a single fixed pulley. So in a single fixed pulley, the mechanical advantage formula first we will write. Load by effort. Okay, single fixed pulley has a mechanical advantage of 1. Load is here 50 kgf and the effort which is here is of fixed pulley, so I am writing it as EFF for fixed. So I will cross multiply, I will get the effort applied in a fixed condition with a fixed pulley is 50 kgf. So I know the effort in when we are using a fixed pulley. Now let us see what will be the effort in case of a movable pulley. So again, mechanical advantage formula, load by effort. Because it is a single movable pulley, you should be remembering that the mechanical advantage is 2. So I write here 2, load is 50, and the effort in movable case, I am writing it as EM. Okay. So effort in movable pulley is 50 by 2. So that gives me 25 kgf. So I know the effort in both the case. Let us compare them. So comparing means always finding in terms of ratio. So I have written effort in case of fixed pulley as first because fixed pulley is mentioned first and then the movable pulley. For fixed we got it as 50 is 2. In movable we got it as 25. So both of them can be reduced with 25 and we get the result as 2 is to 1. Okay. So this is the relationship which we get for the effort applied in a fixed pulley and a movable pulley. Let us take a look at numerical number 4 in a block and tackle system. So we have come to know block and tackle system consisting of 3 pulleys. So altogether total is 3 pulleys. So the upper block will have 2, lower block will have 1. A load of 75 kgf is raised with an effort of 25 kgf. It is a block and tackle system. But since the load and the effort is given, we will have to find mechanical advantage with load by effort, not directly writing 3. Okay. We have to find the mechanical advantage, the velocity ratio we can write directly what it will be for block and tackle system with 3 pulleys, and then we have to find the efficiency. A very simple sum. So let us do it. So load is 75, effort is 25. We need to find the mechanical advantage. So that is load by effort. So 75 by 25. So that gives us 3 is the mechanical advantage. Then the velocity ratio, because it is a block and tackle system with 3 pulleys, number of pulleys is the velocity ratio. So we write here directly velocity ratio is equals to 3. And then we are asked to find the efficiency. Okay. Third part is efficiency. So mechanical advantage by velocity ratio into 100. So if I put the value, it is 3 year, 3 year and 100 year. So it will come to as 100%. So this numerical number 4th is done. Okay. Now very much similar sum is the next one, the 5th one. Let us see, a block and tackle system has 5 pulleys. So upper block 3, lower block 2. If an effort of 1000 Newton is needed in the downward direction to raise a load of 4500 Newton, calculate the mechanical advantage, velocity ratio and the efficiency of the system. So because the load and the effort is given, again I repeat, I will find it the mechanical advantage by using the load and the effort part. So mechanical advantage is load by effort. So here the load is 4500 and the effort is 1000. So 2 zeros cancel, 45 by 10 will give us 4.5. Then velocity ratio will be the total number of pulleys in a block and tackle system, and so it comes to as 5 directly. Now coming to the efficiency part, this was A, B and C is the efficiency part, which is mechanical advantage by velocity ratio into 100. Mechanical advantage we got it as 4.5. Velocity ratio is 5 into 100. If I cancel this, this will be 0.9 into 100, efficiency of this is 90%. So both were nearly the same type of sum. Here the mechanical advantage and velocity ratio got matched, but here they did not. As a result, the efficiency is less than 100%. Coming now to numerical number 6, which is a diagram based one. Let us follow the question in figure 3.31. Draw a tackle to lift the load by applying the force in downward direction. So we have to draw all the tackle here and effort has to be applied in the downward direction. Mark in the diagram the direction of the load and the effort. So we have to do the labeling of where the load and where the effort is there with that direction. If the load is raised by 1 meter, this is the displacement of the load. Through what distance will the effort move? By applying velocity ratio formula, we will do that. State the number of strands of tackle supporting the load. When we do the diagram, we can count and see. And if you have already studied about this 5 pulleys, you will know 5 strands will be supporting the load. And then we have to find the mechanical advantage by load by effort, seeing how many tensions will be related over there. First of all, let us draw the diagram of it. Okay, so because it has got one pulley less in the lower block, the tackle which is there or the string which is there will be from the hook of the lower block. So if it is, this is the hook of the lower block. So first of all, this will be joined and then this strand or the tackle will come from here. String will go to this one. From here it will make a round and then go to the top one over here. From here it will come to this. I am drawing a free hand. When you get this diagram, draw all these strings by using a scale and simply try to draw a tangent. So I have brought it till here. Now from here it will go up to this one. Please try to see when you draw a pulley diagram, especially the block and tackle, don't allow the there should not be any slacking of the string. So if you are using with a scale, keep drawing the tangents to these circles or to say the pulleys you will get. So finally my string has gone here. Now it will come over here to apply the effort. This effort direction I have shown here only. You have the load here, so load will be shown in this way. So the drawing has been done, marking of the load and the effort is done. I will here only first of all show all the tensions which are acting. This effort will be balanced by this tension. Here a tension will be acting in the upward direction. Here also in the upward direction. And here also in the upward, this end of the strand, one tension comes here, another comes in this strand. So altogether this load will be balanced by 1, 2, 3, 4 and 5 tension and the effort will be balanced by this tension. Okay, so all the marking I have done. So A part has been done in the figure. If the load is raised by 1 meter, through what distance will the effort move? So let us come to the B part. Velocity ratio is displacement of the effort by the displacement of the load. So since this is a block and tackle with 5 pulleys, so velocity ratio comes as 5. Displacement of the effort we have to find. So written here as dE. Load is raised by 1 meter. So I get displacement of the effort to be as 5 meter. So B part is done. C part, the number of strands of tackle supporting the load. So we have seen there that number of strands supporting the load. We have counted here 1, 2, 3, 4 and 5. So that is the answer for the C part. What is the mechanical advantage of the system? Okay, we will go with the formula. Mechanical advantage is equals to load by the effort. You can see this load was supported by 5 tensions, so 5T, and this effort was balanced by this one tension T, and so we get it as 5. So we have completed all the parts. What instructions I have given for the diagram to avoid slacking of the string, that is to be remembered. If the strings in your diagrams are slacked, marks are not given. Let us come to numerical number 7. A pulley system has a velocity ratio 3. So velocity ratio 3 should make it clear to you that it will happen in a block and tackle system with 3 pulleys, 2 in the upper block, 1 in the lower block. Draw a diagram showing the point of application and direction of the load, effort and tension. It lifts a load of 150 Newton by an effort of 60 Newton. Load and effort is given. So we can find the mechanical advantage by using load by effort. Is the pulley system ideal? For that we need to find the efficiency. If it comes as 100%, then it is ideal. If it doesn't, it is not in an ideal system. We have asked to give reason for it. So diagram I have already drawn here. Okay. So because it was a 3 pulley system, so 2 in the upper block, 1 in the lower block. So the load is here acting in the downward direction. This tension will be balancing the load, this one and this one. And you can see because the lower block is having 1 pulley less, so I have started with the hook of the lower block. So first this is joined, then the string comes to this bottom one, and from here it goes to the top one, and then the effort gets applied. So all the parts which were told to be marked has been drawn here. Now to calculate the mechanical advantage by load by the effort. So load is clearly mentioned to us as 150 and the effort is given to us as 60 Newton. So 0 cancel, 3 2s are, 3 5s are, so we will get it as 2.5 as the mechanical advantage. Is the pulley an ideal system? For that we need to calculate the efficiency, and for that we need to know the velocity ratio also. So velocity ratio, 3 pulley system in block and tackle system, so it comes as 3. Okay, so now efficiency will be mechanical advantage by velocity ratio into 100. So mechanical advantage is 2.5 by 3 into 100. So that will give me 250 by, I go to divide it here, 3 8s are is 24, 1 is left 10, so I will get here 83, 1 by 3%. So I am not getting it as 100%, so that is why it is not an ideal system. So I will write here, it was asked, is the pulley system ideal? The pulley system is not ideal as efficiency is not 100%. So this was a numerical where you had to draw the diagram also. While drawing the diagram, if you don't practice beforehand, then your diagrams will not come properly. So take a note of how the diagram has been drawn over there. Do use a scale to draw all the strands so that they will come straight. The pulleys which are there in the outer part should always have a bigger radius than the one which is in the inner part. Then the drawing the strands will be easier to draw and you can draw it straight. Now let us come to numerical 8, which is again a diagram based question. So it says figure 3.32 shows a system of 4 pulleys. The upper 2 pulleys are fixed and the lower 2 are movable. So block and tackle system, 2 in the upper block, 2 in the lower block. Draw a string around the pulleys. Also show the point of application and direction in which the effort is applied. So we have to draw the string, okay, complete the diagram and show the direction of the effort. As such, I will explain showing all the other things, that is the load and the tension also. What is the velocity ratio? You know there are 4 pulleys, so it will come as 4. how are the load and the effort of the pulley system related? Load and effort is related with mechanical advantage. So using mechanical advantage, we will do that. And what assumption do you make in arriving your answer in part C? So if I am taking mechanical advantage directly as the number of pulleys, it means I am taking that it is in an ideal condition. So in an ideal condition, what all things comes, we will be writing all of them. So let us first go with finishing the drawing of the strings here. It is a system where the pulleys on the lower and the upper block is the same. So first the string will be tied to the hook of the upper block. So from the upper block, the string comes to the first pulley in the lower block. It will take a round and then go to the below pulley of the upper block. From there, it will come to the bottom pulley of the lower block. The string will take a round and then it goes to the topmost block in the upper one, and then the effort string will come. This will be your effort. This effort will be balanced with the tension. Load direction will be like this, and then here a tension will come. In this part of the string also tension, here also and here also. So you can see that there are 4 tension balancing the load and a single tension balancing the effort. So this part we have done. What is the velocity ratio? There are 4 of them. So 4 pulleys are there. So velocity ratio becomes 4. How are the load and the effort of the pulley system related? So for that, first I will write mechanical advantage as load by effort. Mechanical advantage will be 4. So load by effort. So I will get load is equals to effort multiplied with 4. So whatever is the effort being applied, that multiplied with 4 will be that much times the load will get pulled up. So this is that C part. Now in the D part, what assumption you have made in arriving to this result in part C? Because we have taken mechanical advantage directly as 4, it means we are considering it to be an ideal situation. So for an ideal situation, what all things we assume, we go to write that. So in the D part, for the first point, I will say we have not considered the weight of this lower block. Okay, so weight of lower block not considered. Okay, then second, I will say we did not take into consideration the friction. Friction will always be there, but we have not taken. So friction is not considered. Okay, and in the third part, see, we have applied here effort in the downward direction. Okay, so if the effort was applied in the upward direction, mechanical advantage will change. It will become 1 extra. So we have not used that. We have used 4. So we have taken that effort is acting in the downward direction. Effort is acting in downward direction. So you have understood the concept of this numerical, a very good numerical to clarify certain concepts which get confused when you are doing these numericals. Now coming to the 9th numerical, figure is given and based on that the question is there. So figure shows a block and tackle system, pulleys used to lift a load. So if you see, there are 4 pulleys, so block and tackle system with 4 pulleys. How many strands of the tackle are supporting the load? So we will see 1, 2, 3, 4 strands are supporting this load. Draw arrows to represent tension T in each of these strands. So we have to draw arrows and show the tensions over here, which we will show it. What is the mechanical advantage of the system? So we have to find the mechanical advantage here. When the load is pulled by a distance 1 meter, how far does the effort move? For that we will apply velocity ratio. how much effort is needed to lift a load of 100 Newton. So we have to find the effort when the load is 100 Newton, and then what will be its velocity ratio if the weight of the movable block is doubled. So we will see what happens to it. If you remember what I have been explaining, you must have got the answer to this part. So let us see here. To the ninth one, so how many strands of the tackle are supporting the load? So if I just mark it, 1, 2, 3, 4 of them are supporting it. So I will write here number of strands supporting the load is equal to 4. Then B says draw arrows to represent the tension in each strand. So if I show here, this is the tension, this one is there, and so 4 of them we have got here supporting the load. Remember, the load is here. I will show the direction of it. What is the mechanical advantage of the system? So mechanical advantage, there are 4 pulleys. Because the load and the effort is not mentioned, we directly write what happens in an ideal condition. So 4 is the answer. That was the C part. Now when the load is pulled by a distance 1 meter, how far does the effort move? So for that we use velocity ratio as displacement of the effort by displacement of the load. 4 will be the velocity ratio here. Now load is pulled by 1 meter, so displacement of the effort we don't know, this is 1 meter, so we will get displacement of the effort 4 into 1 as 4 meter. Then how much effort is needed to lift the load of 100 Newton? So for that we come to mechanical advantage is equals to load by effort. So mechanical advantage here is 4, load is told is 100, effort we have to find. So effort will be equal to 100 by 4, that is equals to 25 Newton. So you have got the effort also calculated. What will be its velocity ratio? Okay, if the weight of the movable block is doubled. If you have understood me so long, you have the answer that the velocity ratio will remain the same, because velocity ratio do not change whatever happens to the load and the effort. So F part will have velocity ratio same, that is 4. So this completes this numerical. I hope you have understood the concepts here. Now coming to numerical number 10, it says the block and tackle system has velocity ratio 3. Draw a label diagram of the system indicating the points of application and the directions of the load and the effort. So this drawing had come in a numerical earlier also. Okay. Then a man can exert a pull of 200 kgf. So exert a pull of 200 kgf, that is the effort given. What is the maximum load he can raise with this pulley system if its efficiency is 60%. So now efficiency is given and we have to find how much maximum load he can pull if he can exert a effort of 200 kgf. If the effort end moves the distance of 60 meter, if the displacement of the effort is 60 centimeter, what distance the load will move? Displacement of the load we have to find. Diagram part had already come in the previous numerical, so the diagram is already there, already explained about it. Okay, the same diagram is there. Now we will go to find the numerical part of it. So a man exerts a pull of 200 kgf. So this is the effort is 200 kgf. Okay. Now what is the maximum load he can raise with this pulley system? Efficiency is 60%. So we will use efficiency as mechanical advantage by velocity ratio into 100. But velocity ratio we are not given, but we can get it because it is a block and tackle system with 3 pulleys. So I am writing velocity ratio as 3. Now I go to write efficiency, mechanical advantage by velocity ratio into 100. This is given to us 60. Mechanical advantage, I will go to calculate here. Velocity ratio is 3 into 100. So mechanical advantage 3 into 60 by 100 cancel. 18 by 10 will give me 1.8. So now I know the mechanical advantage 1.8. So using mechanical advantage as load by effort. So mechanical advantage is 1.8. Load we have to find here and the effort is 200. Okay, so load will be 1.8 into 200. So 10 will remove that decimal. 18 to the 36, 10 is left. So he can lift a maximum load of 360 kgf. So this is your A part is done here. Okay, this was the A part. Now the B part, let's see what it is asking us. If the effort end moves a distance of 60 centimeter, displacement of the effort is given and we have to calculate the distance the load moves, so displacement of the load. So velocity ratio is equals to displacement of the effort by displacement of the load. Velocity ratio is 3, displacement of the effort is 60, displacement of the load we have to calculate. So displacement of the load will be 60 by 3, that is equals to 20 centimeter. So I hope you have understood this numerical. We come to the end of the numericals of this part. There is another numerical, 11th one. We will not be doing it because that numerical is based on one single fixed pulley and multiple movable pulley, which is not there in your syllabus. So I hope this entire numerical part of machine will help you in understanding and work out the numericals so that you perform to the best of your ability in the examination. Do remember to subscribe to my channel and like the videos which you are watching. Thanks for watching.